I'm Old Sneelock. Welcome to another episode of Old Sneelock's Workshop. Well, the project for today is to face off both sides of this plate so that I'll have a good smooth surface. The concept is to take this metal block and fit it into this aluminum block so that it will pivot back and forth. The upper wheel on the bandsaw needs to have the axle so that you can adjust it. You want to do that to allow for tracking. By moving the axle up and down, it causes the blade to move either left or right on the wheel. It lets you align the blade with the guides. By moving the axle up and down, it lets you move the blade left or right on the wheel to center it. The rough out got me close. I just need to machine this down a bit more and put the axle in there and get it centered up. Before I can do that, I got to tear out this setup. Shouldn't take too long. Turning between centers has the advantage of being able to take the part out of the lathe, do another job, and then put the part right back in and have it not lose its center. Put on the 4-jaw chuck. Now, if I had a milling machine, I could just put that in the vise and tighten it up, machine it right off. But I don't. The lathe will act as a milling machine though if you use it correctly. First thing I have to do is turn the jaws around. It would be nice to have another 4-jaw. That way I could leave one set of jaws set for internal and the other set for external. But I don't have another 4-jaw chuck. Perhaps one will come along down the pike and I'll be able to get one. Now I take my chunk of steel and I want to have it engage the jaws so that the part is centered. The reason I want the jaws reversed is so I can use this part of the jaw as a shelf to set the part on. I don't have to worry about centering it because it doesn't really matter. All I want to be able to do is clamp this between the jaws and lock it in place. Have to take both of these in about ½ inch. Because it's going to be an interrupted cut, I do want to have my tool stick out as short as possible. I want to have as strong a setup as I can get. Kind of be like hitting it with a hammer about 10 times a second. Well, let's give it a shot. Or just catching along that edge. just the faintest of marks. Let's check our chuck, make sure everything's still staying tight. You really only have to do 2 of the jaws 90 degrees apart. But it's nice to check them all just to make sure nothing's coming loose. And I take a fairly good size hammer. This is a 3-pounder. And make sure it's seated completely into the chuck. Don't have to hit it very hard. Just want to make sure it's not coming loose. Having a power feed compound would be very handy. But it's not something that this lathe came with. And it's not an easy thing to put on there. So facing is a manual operation. I flipped the part over in the chuck. I'm using a round nose tool. Now the reason for that is it makes the load spread out over a larger surface area. If I used a pointed tool, the impact would tend to break it away. But this large surface here has a lot more strength supporting the edge, and it also lets it start cutting with a thin cut and then work its way down to a heavier cut. So the chip is actually not as heavy and it's not as much load on the tool. Not a big deal, but it makes a difference on these little lathes because it lets the tool cut freer and easier. I have to remount the part in the chuck. When I flipped it over, that put this leg out a lot further than what it was. And made it so that the part is swinging around enough to run into the lockdown bolt on the compound, and I don't want that. Tap it down, make sure I got everything up snug. Another check, make sure the chuck's tight. A couple of seconds here makes all the difference in the world. You don't want to have to come back later and pick the pieces out of your chin. Yep, that's going to clear the compound just fine. One thin skim cut ought to take care of it. Okay, that's where the axle mounts. That should get us just where I want to be. Now what I wanted to do is drill this cross piece. What I wanted to do is drill the cross hole in the lathe. I might be able to do that by mounting it on a face plate but I don't think I can get this to center up and let me bore it in the lathe. Facing operation's done. I've got a consistent thickness across this surface. I'm within a few thousandths, which is more than enough for what I need. To get the chuck key past this jaw, I need to have the nose piece thinner so it clears that part right there. So to make that happen, I put it in the lathe and I'm going to turn it down. Now this is not my normal chuck key. Normally I use this small one because it's just more convenient. But the small one doesn't have enough depth to go down inside the chuck, even though somebody has ground the dickens out of it. And with the T-handle welded into it, it's very difficult to get the T-handle out and mount it into the chuck to turn that down. So I'm using this spare chuck key, and I'm going to turn it down so that it'll perform the function. I think I need to speed things up a bit. Carbide cutters like a little speed on them. Okay, now we'll try it on the chuck. Nope, I have to take this section down quite a bit more. Let's see what the result is now. Tool back out of the way so I don't smack into it when I take the part out of the chuck. Well, we're gaining on it. I need to bring this one in far enough so that it acts as a foot for this thing to set on. I don't know if I'm going to be able to do that. I might have to come up with a different method. If I put a crisscross in there, in the center, that might give me enough to hold that. Well, that'll catch it and act as a base, but then that makes it so that there's nothing really gripping the thing, because I can't use this jaw at all. I can just leave that screw out of there while I'm doing the adjusting. Saved me a lot of fiddling with the thing. Let's see, if I was drilling this by hand, my only difficulty would be trying to hold a hole straight all the way through the thing. The machine lets me do the hole much more consistently, but it's a lot harder to set up. And the answer to the machine problem, to make it easier to use the machine, would be to go with much more sophisticated machinery. To allow me to use the machine to do more of the work. I gotta go ways yet. Not out of the woods. Not out of the woods. And that'll go down and grip. Now this jaw will go down and grip that side, and I can come up and grip the other side with the other jaw. A lot of fiddling. Much harder setup. But we got a functioning part. Process looks to be okay. Well, the tool's scribing a consistent line across the surface of the part. So that tells me that I'm perpendicular to the chuck. I'm locked in solid. But before I do that, I want to face off that piece. And I'm only going to be able to face this side because the other side is going to be a lot more difficult to chuck up. I might possibly be able to do that, but trying to face out here would be terribly difficult. I think I'll more than likely, since this is 99% square anyways, I might just leave that alone. The bearing surface is not the end, it's actually the rod. What I want to do here is face that off so I got a good shot at centering up the drill bit in there. Got to do light cuts because I'm really not very stable. With that much eccentric mass on the chuck, I get a lot of wobble out of things. Just a little further and I'll be past center. That's all I really need. Well, we're ready to center drill.
We're going to leave the rest of the drilling operation for tomorrow because it takes a long time to drill that deep a hole. And I don't want to just skim over it because it was interesting. If you have any suggestions for a new video, questions about today's video, or any of the other videos on the channel, just drop a note in the comments. You know I read them all. Thanks for watching.